Good morning, everyone. Good morning. Delighted to see so many of you here this morning. So my name is Christoph Nijs. I'm part of the field engineering team at Neo4j. So our job is there to explain what our technology can do. And the topic of today is GraphRAG. So what do we mean with to boldly go when no one has gone before? What we're going to try and explain here for the next 30 minutes or so is that through GraphRAG, you can have a conversation with your data. So an interaction with your data that is accurate, contextual, and explainable. Okay? So that's the topic, but equally my mission is to get you started on your GraphRAG journey. So we'll show you an example, and more importantly, the software that Neo4j provides is entirely open source. We have web-based applications, and so hopefully at the end of this talk, you'll come and see us at 328, where my colleagues and I can basically help you get started. With the various applications that we have. We have both, as I said, web-based as well as LangChain functions, etc. So before we go there, we'll go a quick outline. So we're going to give you first a bit of the context here, what the state of Gen AI is at the moment. Industry has converged towards RAG, so we'll spend a minute or so on what RAG is. Then we'll have a look at what knowledge graphs can do. We'll explain, for those who are not that familiar with knowledge graphs, how they work. And then, of course, we're going to move from RAG to GraphRAG. I'll explain all of that in detail as well as the context. RAG stands for Retrieval-Augmented Generation. And if you really want to serve your customers, your users, then you want to improve the R. And that's what we're going to see, what we're going to do. And then we'll actually show a little example, short demo. But as I said, if you want to have a more detailed demo, please come and see us at our booth 328 after this talk. And then we'll have some validation. We'll have a look at what is currently playing in industry and how is it being applied. Okay. Before we kick it off, quick word from our sponsors. Who is Neo4j? Neo4j established the graph database market all the way back in 2010. In the meantime, we've developed or expanded our software to include an analytical engine, through our data science offering, as well as visualization tools. So it's an entire graph technology platform. Certainly equally important is that, as I mentioned, it's open source, so you can get started without any cost in your projects. And then if you want to take it to the enterprise level with all kinds of support, and of course, lots of the large companies, maybe almost 70% of all the large companies use Neo4j in either some form of on-prem or any of the cloud providers ultimately. So, brave new world, Gen AI, GPT, etc. started, what is it now, about 2 years ago, and many of us are wondering how did we ever live without that. It can basically pass exams, it can do something, write stories for my 5-year-old, etc. So it's fantastic. I use it, I'm sure you use it on a daily basis. It's also a little bit funny at times, if you ask it in the wrong way, can I cross the channel, the English channel on foot? It will go yeah, it's not easy, but you can do it 14 hours, go, 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 good luck with that. And then also, we've all seen these situations or these stories about Gen AI coming up with things and then people using it in the wrong way. And there was this lawyer back in New York who basically submitted some papers to the court, to the judge, and ultimately he simply asked ChatGPT to write it and everything was made up. And the guy is basically being fined, etc. So I think we all conclude now that ultimately Gen AI on its own, that is something that you can't really rely on it, and it's not really applicable. And part of that skepticism that has been developed, so to speak, or evolved rather, is that Gen AI is often compared to a stochastic parrot. Why? Because a parrot just makes up random things. It sounds very credible, often talks nonsense, but what's the difference is that one is a cute little bird and GPT is not, right? So those are kind of like the jokes that are going around. And then that contributes as well to a skepticism that runs with large enterprises, right? So a lot of these surveys are showing that Gen AI ultimately, if it's not explainable, how can I base a decision on something which I don't really understand where it's coming from? And then in many cases, there's been a lot of evidence where these things are just hallucinating and are not reliable, right? So As a result, only or less than 5% of companies in the US are now using some form of AI application, and that also gives you the scope, the potential of, if you build a good Gen AI application, how much more you can basically do and indeed sell if you're in that space, right? So that then brings us to what we want to solve for today, what GraphRAG at the enterprise level will solve for, is we want to come up with an application that indeed uses GenAI, but where we have answers that are indeed accurate, that are giving you context, and that is explainable, right? And so that's where, hopefully you will agree with us after this, GraphRAG comes into play. But given that problem statement, the industry over the last, 2 years has converged to this thing called RAG, Retrieval-Augmented Generation. And so let's define it first of all. What are we talking about? So it's basically an ability that you compose a large body of text, a text corpus, that provides your knowledge, right? So that is basically providing the source of truth, and then you're feeding whatever query, dynamic query you release on that large body of text to the LLM, for the LLM then to generate the answer. So as a result, you do not rely on an LLM on its training to come up with information, with facts. No, you restrict that to some database of truth. And even if you want to fine-tune a model, you're still running risks of hallucination. You never can fully exclude it. Hence, this business of RAG was developed. So what is the typical workflow? In a RAG, as I mentioned, you have some database of truth, and you have a particular user question. That user question gets converted into a query. That query runs on this database of truth, and then the results of that query, remember that database of truth contains this factual information that you have, then the results of that query together with the question to get the context gets fed to my little parrot, and only that information is being used to generate an answer, okay? So that is typically the workflow. Now, over the last, year or two, that database of truth has become increasingly more a vector database, okay? And why is that? Part of the reason is that, yes, ChatGPT can generate amazing answers, but these models, these large language models, have also the ability to encode text, audio, video, etc., in addition to summarization, text extraction, etc. So they're much wider. And this ability to convert any piece of text, video, image, etc., to a numerical representation, that is to say to a vector, using a simple API call, has resulted that these vector databases are now providing the database of truth. So any piece of text, document, etc., gets converted into that vector representation gets stored. Vector database of truth, you can do cosine similarity. These are simple vector similarity searches that you can do, and there's various methods around in order to speed up that process to limit the computational cost. So that is what is now being very much applied in industry. And let's have a look at what are the drawbacks and issues around that. So vector database of truth ultimately allows you to, yes, indeed, search that information, but it doesn't fully give you the context, right? So you have metadata that is stored in specific vectors, but that not always rely or relay basically the relationships between them, okay? And so as a result, you never get the full context. And don't worry, I'm going to show you later on what we actually mean with that context, right? So it's limited in the context that it can provide. And finally, a cosine similarity doesn't really give you much explainability, right? So if you're familiar with the formula, that doesn't really give you much explainability. So there's a lot of drawbacks. It definitely works. It reduces, if not eliminates, hallucination. But the question is, can we do better? And can we go to our quest of accurate, contextual and explainable information? And so that's then where we believe the knowledge graph can help. And so let's double click a little bit on what we mean with the knowledge graph. So you may have seen this definition of us in the past, and this graphic in the past. So this is in its widest form, the definition, the academic definition ultimately, where basically you have, and I'll explain you the knowledge graph. So you have entities that are represented. So we have Andre, Mika, we have a car, the brand node, we have the relationship determined. But I think what is key to understand and to focus on for the purposes of today, if you look at these properties that are attached to these nodes, these entities, what do we have? We have a key value pair. So we have brand, Volvo, model V70, description, some string, blue car, red seat, yellow tires. Now that string, I can expand on that string, that can become a chunk of text, and you can already see where this is going. In addition, I can add properties to the relationship, so I can have weighted graphs, also very important, very powerful. And so what we have now in this sort of like, as a result of encoding models being ubiquitous, is that we can come to sort of like a new generation of knowledge graphs, as it were, and that is to say we can add vectors to these knowledge graphs. So we can combine. And so let's have a look again at our little toy example here. Remember our car node, we had to describe green seats, red tires, what have you. Well, because I can just convert that now with a simple API call, and I have the ability to write the property to each node, I can have, together with graph traversal, which we'll see in a minute. That's why we're saying these are sort of like the new and enhanced knowledge graphs 2.0, and that allows you to combine, as I was saying, the vector search. So Neo4j has that in the database. So about a year ago, we've done exactly what you have in your Pinecone, your Weaviate, whatever vector database you are using. You have a vector indexing procedure. In addition, you then can combine the text search with this sort of like vector search that we have. And in addition, we then also can do a node embedding. We have encoding models in the library. And I'm mentioning this because hopefully part of your GraphRAG journey will deploy these kind of tools. And so as a result, Neo4j is now in the LangChain library in one of the top 10 vector databases. So we're not the only one who believe in this stuff. Gartner has come up with that as well extensively to say, look, knowledge graphs will be part of some form of Gen AI application in the future. Right, and then let's have a look in a minute about how we then can build up GraphRAG. And by now you must think, well, this guy from Neo4j looks like a nice guy, but clearly he's had some mushrooms for breakfast because all he thinks about is graphs. We're not the only one who believe in GraphRAG. So there was this paper that was published about 6 months ago from fairly well respected team at Microsoft, where they basically constructed a project, showcased GraphRAG, and also defined GraphRAG. And the definition of GraphRAG is a lot more extensive. There's a lot more components that go into it. And then the key point to focus on here is that you can do, these are methods to do text extraction, to do network analysis, and we'll come to that in a minute. Also, of course, to rely on the LLM prompts, and indeed agentic approach, and then, of course, the summarization. So these guys have sort of like really, that paper has gained a lot of attention, has really put a lot of sort of like oomph in the whole movement, as it were. And then how does that workflow then is implemented in Neo4j? Of course, at its core, you have your knowledge graph as your database of truth, which is very versatile. As we showed, you can add the vectors, etc. And this ability to add vectors, well, that allows us then to use a user question, convert that user question into a vector representation, exactly like what I do in a vector database, and then do a vector search on my knowledge graph. On my graph database, I do a similarity match on those vectors, and I'll show that to you in an example in a minute. The results of that query, which I'm deploying vector search, together with, of course, the question, then gets fed into my little parrot, and I'll let my little parrot generate a good sounding answer. In addition, by having a graph database such as Neo4j, I can do basically role-based access control, which means I can hide some parts of the graph certain people don't always get to see it. And so we're not the only one, as I said. In the meantime, lots of research has been done on this one, and actually only a month ago a paper was published highlighting a lot of these sort of like various applications that you can do, and indeed we'll see in a minute what has been applied in industry as well. And then, as I was saying, so what you really want to get to serve your customers better, you want to go to a better retrieval, right? So a better retrieval part of your RAG. And so we're going to do a little quiz. And also here at Big Data, we're here also to make friends, long-term friends. So I'm going to ask you a question. I'm going to show you a little image. But I suggest I'm going to give you 30 seconds time or something because we're limited. But collaborate. Speak to your neighbor and come up with an answer. First team that shouts up, come and see us afterwards. We have a little prize for you at the booth. So collaborate. Give you 30 seconds. The question is, where is this and what is this? All right, we'll kick it off here. Sorry, I can't hear. No, it's not Paris. It's not Paris. It's not 7 Bridges of Königsberg. Anyone else for that one? So here we go, 7 Bridges of Königsberg. This was basically, this is the current Kaliningrad. and the reason why we're showing this is the birth of graph theory, graph data science, as it were. That is to say, Euler back in 1736 developed, came up with a proof that you can't cross these bridges only once and come back to the same point. That's what you did at the time on a Sunday afternoon. You and the family walked around and you tried to cross the 7 bridges as a pastime and so yeah, for fun, and he proved it, and with that established a major branch in mathematics, and with that a whole ton of algorithms and models. And so this is at the birth of graph theory. And so with those models and algorithms, they are now also at your disposal in Neo4j. Not only that, one of the reasons why you're showing this is that Microsoft, remember when they were doing the definition, network analysis was a core component of it. So they deployed an algorithm that does community detection on your documents to summarize it, right? So if there's any Dutch people here, they use the Leiden algorithm for community detection. So you finally, your fame to claim, as it were. So that's why we believe that we're sort of like an inflection point that allows you to talk to your data. And there's 3 major components that allow you to do that. We believe the knowledge graph as a data structure at its core. You want to enhance that with the analytical engine that you can, that there is graph data science. And then of course you need to include that vector search. You want to have the best of a vector database together with your graph database, right? So let's have a look at an example. What we're going to look at is now many of us, many enterprises need to do requests for proposals, need to send off requests for proposals, and let's suppose you need to write a request for proposal that runs on AWS, okay? So what is the problem, not problem, what are the challenges with these sort of like requests for proposals is that you, that they're time consuming, so that is to say, you need to obviously do it manually, write it manually. You need to research past requests for proposals, etc., right? And then the other key problem is it's text, it's unstructured data, right? So you have unstructured data and you need to go through it, all of these things. So we want to build an application that ultimately allows us to build up a knowledge base, so it's domain-specific knowledge base of these documents, right? So that I don't need to do it manually ultimately, and that I have a store. I want to make sure that I can then ask questions of that knowledge base, and indeed help me write such a proposal. And I want to make sure that I'm flexible. That is to say, every day, every time, every week, whatever the period is, that I'm having to write a new request or proposal, I have flexible storage. I can store that, okay? So that's the challenge, and so let's have a look at how to do that. And again, I'm showing this because we'll see in a minute that this is something you can do with your documents. In Neo4j, we have both a web-based tool where you can upload your documents as well as an entire library in LangChain if you want to sort of like do it more yourself. So now let's suppose this is your typical RFP. So we call it AWS RFP. Every document has some form of introduction, some form of objective, and then some like to the point things like paragraphs, etc. And they have always got some subsections, right? But really, if you think about it, that's not just an RFP. Many documents are like that. Academic papers are like that. Annual reports are like that, etc. So there is an element of hierarchy in those documents. Well, if we have that, and if we now have these tools of text extraction, chunking, etc., well, we can combine them and we can do stuff with that because we can actually represent this as a graph. So let's have a look. I can take each of these, so like subsections, etc., and represent them as nodes, okay? And so I have, of course, the overarching node, which is the document. Then I have the subsections, which is the intro, the objectives, the proposal. Then I have the subsections, as it were, the paragraphs about the company, the financials, and what have you not. And then that subsection, I can split it up in chunks of text. Now remember when we were looking at the car, yellow seats, green tires, etc., those strings, they can be quite expensive. So I can add those chunks to these text chunks to the nodes. And what do I have now as well? With a simple API call, I can convert those chunks into a numerical representation, a vector. Happy days, because now I'm off to the races. I can build a wider knowledge graph. So I can then basically see if I can do that for many documents, right? So I can do it for one document, but I can combine I can construct that for every single document and build up a much larger knowledge graph of the entire repository, right? And I'll show you in a minute what we can then do with that larger knowledge graph. So I can do flexible storage, graph database is schemaless, I can just add new nodes, new relationships, and what have you. And then once I have that large knowledge, that combined knowledge graph, of course I have a knowledge base. I can then search that knowledge base. Not only that, I can find similarities between chunks of text which are of different documents in that larger knowledge graph because, of course, I've got vector search at my disposal. I can do cosine similarity and what have you. So I'm addressing those two kind of things already through the knowledge graph structure. Now let's have a look how to put that into practice. Let's now say I need to ask a question from an RFP. Let's say who is the main respondent of the AWS RFP, a question. Well, I'm going to do the same workflow as I'm doing in my vector database initially. I'm taking that question, asking an embedding model. Let's say you're doing this on AWS, you're using Bedrock. I think they was presenting just before me here. That question gets converted into a vector representation. I can then do a vector similarity match, right? So I'm just doing a vector match. That is a millisecond operation. Why? Because I've indexed those vectors. And if you have some technical questions around the indexing, etc., come and see us afterwards. And then once I have that vector now matched to a document or a chunk rather in my graph, from there I can do this thing called graph traversal, okay? So I'm doing a vector match between the query vector, which is the question, whatever I've got stored in my graph database, I can have a lot of vectors in there, millions of vectors, and then from there, so like, who's the main respondent? Well, that's ABC company. That would be the same result if I get from my vector database, but immediately from that vector match, my node that vector is attached to, I can do a graph traversal. So I can immediately see, oh, okay, it was ABC company. Who at ABC company? Who signed for that document, etc. So I can immediately get a much wider context around simply the vector match. And so that satisfies the second thing that we want to do, is get a contextual answer, of course. And that is not something I can get from purely doing semantic search. I can take this to the nth degree. Come and see us afterwards if you want to see what the scope of possibilities is. And then the other thing I can do is, of course, I can hide certain graphs on my certain parts of my knowledge graph if I want to make sure that certain users don't have access. Let's say I'm working in an HR department and I don't want to see show the pension contribution or pension benefits of my CEO to everyone in the organization, for instance, right? So I have extra security levels that I can add. And then once I have generated that answer, as I said, I have a similarity that I get matched, the results of that query, so the nodes that it's visited, the relationships that have been traversed, the results of that those query, I can then feed it into my little parrot. I say to my parrot, only use that information, and that's what it does. It says the main respondent of the AWS is John Smith, yada, 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 right? So that's basically how your typical workflow, your GraphRAG workflow happens. But what we haven't shown here is that I can actually even improve it. And again, here's a little teaser to get you to the booth later on to show you how we do that, is I can add PageRank scores, for instance, to the most relevant documents, right? Not just the best semantic match, but the most relevant documents, like what the team at Microsoft did. In order to construct the document, they ran community detection algorithm on it, such to have a much better representation or summarize, chunking up of the document, etc. And I can take it even further. Once I have a knowledge graph, I can continuously learn on my knowledge graph to find implicit relationships. Because, as I mentioned earlier, I can also do a node embedding. Once I have a vector representation of my graph, I can feed it into a machine learning workflow and do link prediction. All kinds of good stuff. So come and see us afterwards. And so, as I said, this is all at your disposal. We have a free-to-use web-based tool. You upload whatever PDF document or whatever media document you have. It reads it in, so it chunks it up. It represents it as a graph. And then you can, through a chatbot interface, ask questions from that document. So all you need to do is to basically give your name and email address and you're good to go. For those versed in LangChain and want to do it themselves, we have an entire library in LangChain that allows you, and a module that allows you to do that as well. And then so like to wrap it up, because I'm running out of time here, I've been told, is, yeah, we say that, we're seeing a lot of evidence in research, but are others doing this as well? And I invite you to have a look at this work that LinkedIn has published, where they report on an application that they've built to satisfy or to serve, to answer customer services questions, right? So if you have a corporate account or enterprise account, you can ask them questions, etc. And they managed to build a GraphRAG application and reduce the answer time by give or take 29%. So those are pretty powerful, pretty meaningful results, of course. And good for us, they actually build it in Neo4j. So if you look at the paper, you can exactly see the workflow. You can even see the queries that they've written as well. So there's clearly validation here of the technology. And then on the biomedical side, these guys, it's maybe not so like at the enterprise level, but they've compared, what if you just do an LLM with advanced prompting compared to a knowledge graph RAG system, GraphRAG, how the retrieval results, the Q&A results perform on various benchmarks, right? And so as you can see here, or you may not be able to see it, but so like the graph or the results on the right show the performance of the GraphRAG based system, right? So a lot of validation, and again here we're just showing this, that we're just not making this up. This thing works. LinkedIn has proven it, etc. So I'll leave it there. Thank you for spending some time here with us. As I said, come and see us at the booth. 328 is the booth where we'll get you going. And also if you want to have a copy of the slides, etc., come and see us. So hopefully I'll see you there, and thank you there, and thanks again for spending some time here. Thank you.